Hello my dear friends, welcome to Yourpedia. So in this session we will discuss the top 20 question, or you can say the most expected question of BEL Bharat Electric Limited if we talk. So I will take the that is basically from the SOM and top 20 question, or you can say the most expected question of strength of material. We will try to cover in that one. But yes, so let's start with the first question my dear friends. The first question on your screen. And this is Poisson ratio is expressed as lateral strain upon longitudinal, longitudinal stress upon longitudinal strain, lateral strain upon longitudinal strain, lateral stress by longitudinal stress. So what can be the answer? Poisson ratio my dear friends. So what do you mean by Poisson ratio? So simply we can say, suppose this is one of the object, right, on which you are going to apply the force F. So here we can say by application of that force what will happen? Length of the object will increase, right? Length will increase. It will become something like that. Okay, initial that was length Li and after final length will be LF. But meanwhile we can say that is initial width, let's assume B, and that one is BI, and it one is what? BF. You can say final width. So here we can say as the longitudinal length is going to be increased, then we can say what is happening in the lateral? It is going to be decreased. So Poisson ratio basically gives the relation between that. This is what? Lateral strain upon what my dear friends? Longitudinal strain. But you know one thing that you have to be just keep in mind my dear friends, as the here we can say the longitudinal strain is positive. What is strain? Change in length upon original length, na? So we can say sir LF minus Li upon original length Li, that is longitudinal strain. We can say longitudinal change in length upon total length. But if you talk about lateral, what is happening? Lateral, the dimension is going to be decreased, that means it is negative. So if length is increasing, other dimension is going to be decreased. That's why I am going to use here what? Minus sign. That minus sign basically indicate that there is a inverse relation between the lateral and longitudinal. If lateral is increasing, that means longitudinal will decrease. Like if you are going to be compressed rather than extension, you are going to be compress it, then what will happen? Their length will decreases, but other dimension will what? Increases. So that's minus sign here indicate. So what can be answer my dear friends? C for Chennai is the right answer. Lateral strain upon longitudinal strain is the right answer. Come to the next question, and that value sometimes you have to be rubber, basic, that is 0.5, cork is 0. Try to be remember that one also, going to ask various times in different exams. Now the relation between the modulus of elasticity, modulus of rigidity and bulk modulus K is given by. So what is the relation my dear friends? 3 kg upon 3k plus g. That all are the option my dear friends. One option is 9 kg upon 3k plus g. So what can be answer here? Simply we can see here from this, you can say the answer will be what my dear friends? That relation you have to be keep in mind. 9 kg upon 3k plus g, 9 kg upon 3k plus g. Okay, so that relation you have to be just keep in mind. E equal to 9 kg upon 3k plus g. Okay, so that relation basically there is a what? All the relation E, K, G, they are basically three relation which you have to be remember in that. Various times in every exam we will find at least one formulas on that. In every exam one formula is going to ask. E equal to 2g into 1 plus mu, E equal to something like 2g into 1 plus mu, E equal to 3k into 1 minus 2 mu, E equal to one formula is 2g into 1 plus mu, mu is Poisson ratio, or E equal to 3k into 1 minus 2 nu. So try to be remember all these formulas. Okay, because in your BEL exam at least one formula we can expect, right? So try to remember these three formulas which is most important. Next, coming to that question, maximum shear stress in Mohr circle is equal to, that is the question has been taken from the Mohr circle, or we can say the complex stress and strain from that chapter, that question has been taken. So if you talk about how you can get the maximum stress in the Mohr circle, my dear friends, 2 and 3 point you have to be just keep in mind about the Mohr circle. 2 and 3 point, that only sufficient. What? First thing that you have to be keep in Mohr circle. Mohr is a circle, na sir. So obviously there will be center. Circle we can make, there will be center. So my dear friends, just one point you have to be always keep in mind. Mohr circle center will always lie on the x-axis. Always lie. That is the first important point that you have to be keep in mind. Yes, I will go through the derivation in the class. I used to go through the derivation in which I used to prove that radius of the center of the Mohr circle always lies on x-axis. That means it can be something like that, it can be something like that, it can't be, it cannot be like that. This Mohr circle is incorrect, this Mohr circle is incorrect. Their center always lie on the x-axis. Okay, here this is longitudinal, you can say normal stress, or here I am going to get the shear stress. Y-axis is shear and this is what you can say the normal stress is there, right? So the question is that here, that point that you have to be keep in mind. Okay, okay, one more thing that I want to tell you, for the making of any circle, how many things requirement do you have? So sir, if I get two information, I can draw a circle. What? Where is the center of the circle and what is the radius? If I know two things, I can draw the any circle. So here first thing that you have to be keep in mind, center will be always is what? Sigma x plus sigma y upon 2. Okay, or 0, that is the center of Mohr circle. And radius you can also calculate by using the formula sigma 1 minus sigma x minus sigma whole square plus tau x square. We can say like that, sigma x minus sigma y by 2 ka whole square plus of tau xy whole square. These two, if center of the circle and radius is known, I can draw. Now come to that question. The maximum shear stress. So we can say what is that? Is the maximum shear stress na? That is the maximum na? That is the maximum na? So maximum shear stress is what? That is basically radius. So we can say radius of the circle, that means A is the right answer. Diameter of circle no, center of circle from y-axis no. So correct answer is what? Radius of the circle. This is what maximum shear stress. Come to the next question. Here if you have to calculate the tau max, try to remember that one. Maximum shear stress is given by sigma 1 minus sigma 2 upon 2. So that one is also formula very frequently is going to work. So try to be remember. Sigma 1 sigma 2 is the maximum minimum, you can say the normal stress. That is the next question. Again simply in this case we can say, if you go through that, you will get a Mohr circle is what? Point. So the correct answer will be the C for Chennai. It will get what? Point. Next question on your screen. For an element in a plane stress, the plane of algebraic maximum shear stress occur at 90 degree at the principal plane, 45 degree to the principal plane, and at the above. So my dear friends, you know the shear plane, or you can say the sorry, maximum shear stress plane generally occur at an angle of 45 degree. So we can say at an angle of 45 degree from the principal plane. At this you are going to get the maximum shear stress plane. So that is the right answer. That is the next question, my dear friends. I know in BEL less numerically or little bit you can say not numerically is going to ask, but for the sake of in being in the safe region, right, I am going to take just a few type of question which can expect, which is very easy calculation is there. That's why I am going to take some question. Question is that the state at a point 2D loading is such that the Mohr circle is a point located at 175 megapascal on the positive normal axis stress and the maximum minimum principal stress respectively from the Mohr circle are. That means you have to calculate sigma 1 and sigma 2. So my dear friends, I have coming with the answer here. We can see you have to calculate sigma x is there and sigma y, both are tensile is there, 175 and 175. You have to calculate the maximum shear maximum normal stress. So formula is sigma x plus sigma y by 2 minus plus minus root under of sigma x minus sigma y by 2 ka whole square plus of tau x square. Okay, this one is inside that. So just put that value 175 plus 175 plus 175 minus 175 upon 2 plus 0. So ultimately you are going to get the what? 175. So both will be have the same. Next, on principal plane the shear stress is, what will be shear stress on the principal plane? 0 unity, double the value of principal stress, half of the value of principal stress. On principal plane the shear stress is what? On principal plane what can be shear stress? Obviously keep in mind, on the principal plane the shear stress is always what, my dear friends? Always 0. So we can see here 0. Next question. The next question is that the point of contra fracture is a point where. What do you mean by point of contra fracture? Basically, point is the contra fracture is that point. Here bending moment changes its sign. What do you mean by bending moment changing its sign? Means if bending moment is being positive to negative, so the point at which bending moment changes its sign from positive to negative, that particular point is known as what? Point of contra fracture. So my dear friends, if you talk about point of contra fracture, so shear force changes sign, no. Bending moment changes sign, shear force is maximum, bending moment is maximum. So here we can say B for Bombay is the right answer, where bending moment changes its sign. Suppose this is and like that. So that point is called is what? Simply we can say the point of contra fracture where they have changes their sign. So simply that thing is. Now come to the next question. When shear force at a point is 0, then bending moment at that point. Suppose at any point is there where shear force is 0. You know how you can calculate the shear force. So you can say, sir, dm upon dx, if I am going to get, then I am going to the shear force. So sir, in the question is that where shear force at a point is 0. So sir, if this is 0, the bending moment at that point is what? 0, minimum, maximum, or what? When the shear force is at a point is 0. Okay, so here we can say, just make it correct, shear force, or we can say I am coming with the answer also here. We can see that a relationship between the force and bending moment diagram, V equal to dm upon dx, right? So if shear force is 0, means first derivative of the bending moment is 0, means point of bending moment will be the maximum. What can be it? It can be the point of what, my dear friends? Maximum. So correct answer will be the C for Chennai, where you will get the maximum. That value you have to be keep in mind. V equal to here shear force dm upon dx. In fact, sometimes what's happened, you have given the bending moment, and then their slope is going to be indicated by the shear force. That means slope of bending moment gives the what? Shear force. So simply this you can get that point. Next question, a beam is loaded as a cantilever. Okay, if the load at the end is increased, then the failure will occur in the middle, at the tip, below the load, anywhere, or at the support. A beam is loaded as a cantilever. Beam is what? Cantilever. If the load at the end is increased, that means if load is going to increase, then which type of failure is takes place, my dear friends? Suppose this is your we can see cantilever beam. Here it is fixed, and you are going to increase the load. As load is increased, we can say, if you talk about whatever, if you are going to be load, so there will be one of the reaction, and which will be equal to that load W, that will be equal to W, and it will try to rotate in the clockwise with magnitude W into L. It will try to rotate in the clockwise. So a couple will generate it in the what? Anti-clockwise to resist that one. So as I increase the W, the shear force as well as bending moment increase at the point where it is fixed, and if they will fail, so here maximum shear force as well as bending moment. So if the chances is failure, then it will take place from the fixed point where it is fixed. So try to be keep in mind whenever if you talk about cantilever beam, and if you are continuously going to increase the load, especially at the end, so if the fracture is takes place, then it will be from the point where it is fixed, because their shear force as well as bending moment increases at a point it will reach when breaking can be takes place. Next question, a simply supported beam of a span length, simply supported beam is there like this is a simply supported beam of length L carries a point load at the center. No, there is a point load, let's assume W, which is at a distance of L upon 2. The shear force diagram will be a rectangular, a triangular, two equal and opposite rectangular, two equal and opposite triangle. So what you can be, my dear friends, if you are going to draw their SFD shear force diagram, how it looks like, anybody? Simply we can say, sir, reaction will be, this will be the reaction, let's assume that is point A, that is point A, B. So simply we can say, sir, for the calculation of SFD, you can say the RA plus RB should be what, my dear friends? W. if you take about moment about any point, let's assume A, so we can say sir R B gune L is equal to W into L by 2. So from there I will get RB will be what, W by 2. So this one is W by 2, this one is also W by 2. Now make, so you are moving from left to right, so upward, so it will be W by 2, going down down down, at that point W you have to be come down like that and like that, okay, and then again like that. So that will be your SFD, we can say, which will formed. Now see, what is this? A rectangular, a triangle, two equal and opposite rectangular, two equal and opposite triangle. So two equal and opposite rectangular is there. I am not taking to the scale. So we can say what can be answer, my dear friends? C for Chennai is the right answer. This is not up to the scale, okay? Here two equal and opposite, because it is acting at the center, na? So it will be like that. We can see here I have come with the solution also. Here I have drawn the BMDW bending moment diagram also. It will be the triangle, like, okay. So we can just, for that one we can take any. So it will rotate in the clockwise direction, RA into X, take a section XX from that one for getting bending moment, RX into what, in clockwise, and the variation is what, linear. So simply we can get that one, that one. So try to remember that question has been asked, and it is better to understand how to draw SFD and BMD. There are a few rules, like in case of SFD, as you move from left to right, upward force is going to be up. Here we can say up, so up. Here W is down, so W upon this, you have to come the down W, so that one is W by 2. So by this way we can get very simple. Bending moment is same here, we can get, if you are moving here, we can say the clockwise, left to right, clockwise is what, positive. And how you are going to draw that linear, because here you can see this is what, power 1, that means it is what, my dear friend, this is just a linear. So that's why you are seeing here this is a linear. As X will change, X will changes, this will keep in changing, right? Okay, now come to the next question. The moment diagram for a cantilever beam whose free end is subjected to bending moment. The moment diagram for a cantilever beam, which type of beam is there? Again, cantilever beam is there, okay, whose free end is subjected to bending moment. This one, this free end is subjected to bending moment. So what will be their bending moment diagram, my dear friends? What will be? Triangle, rectangular, parabola, or you can say cubic parabola. What? That is the case in which you are going to be see like that. Tell me. So we can say, sir, directly I can see, if I am going to apply M in that direction, there is a reaction will generate in that direction, okay. So if I, let's assume that is a 0 line, okay. So if I will take, that will be constant, so like that, that and that, this way I will get that one, like that. So it is what, my dear friends, it is clockwise, it will come in the down, better to that one we can say. Anti-clockwise, na, moving left to right anti-clockwise, so we will get something like that. So what, that is what you can simply say rectangular, because constant everywhere, nothing is going to be changed. So we can say that is the BMD, that is shear force. Here shear force will be the, everywhere will be 0, because there is no any shear loading acting. So shear force will be 0 throughout. Only bending moment you are going to find. So that will be there what, bending moment. Shear force is 0 everywhere, because no shear force is there. The point of contra flexure is also called as, okay, that is a very new question I have seen in the book, has been asked in different exams few times. The point of contra flexure is also known as, this is known as points of inflection, and that is virtual hinge. Both the name is given to the point of contra flexure. So sometimes in the exam that may ask that what is the meaning of virtual hinge, what is the meaning of point of inflection. So basically that talk about the point of contra flexure. So correct answer will be the C for Chennai. This is what, point of contra flexure. So don't be confused about that, okay. That's why I am coming with the question, so that whenever you are going to find that type of question, you need not to be worried about that, right? Now this is the next question. A solid circular shaft is subjected to bending moment M and twisting moment T. Okay, what is the equivalent twisting moment T which will produce the same maximum shear stress as the above combination? So what can be answer at that, my dear friends? In the class usually I used to prove that. Here I am not going to prove, I am just going to give the answer, but that is important. So what can be answer here, my dear friends? Anybody make a comment? Yes, C for Chennai is the right answer. Try to be remember that one. Root under, if you talk about equivalent twisting moment, it will be root under of m square plus of what? T square. This is called equivalent twisting moment that you are going to get instead of that one. So try to be remember that formula directly. Various times you will find that type of question in your exams. Next question. Bending moment M and torque T is applied on a solid circular shaft. If the maximum bending stress equal to maximum shear stress developed, then M is equal to. Bending moment M and torque M is applied to a solid circular shaft. Suppose this is your solid circular shaft. Okay. So bending moment M and torque T. So torque like T or bending moment, let's assume M. Both is going to be from here M. M is going to be applied. If the maximum bending stress equal to maximum shear stress. Maximum shear stress. So what is the formula of maximum bending stress, my dear friends? See there. Maximum bending stress is given by 32M upon pi d cube and maximum shear stress is given by 16T upon pi dq. Try to be remember sigma b max, that very frequently I will use in the class, 32m upon what? Pi dq. And if you talk about maximum shear stress, this will be equal to 16t upon pi dq. Try to remember both are equal now, both are equal. See there, both are equal, so that will be going to be cancelled out. So M will be what? 16 upon 32t. So we can say, sir, M equal to half of t. So that is the relation. So what relation hold that one? Let me see. B. Yes, B is going to be hold that one. So that is the right answer. So then M is equal to half of t, or you can say t upon 2 or half of torque applied. Next question. For a round shaft subjected to pure torsion, that is the question of pure torsion, the shear stress at the center will be. The round shaft subjected to pure torsion, the shear stress will be what? So my dear friends, if you have remembered that relation, see here, T by J, G theta by L, tau by R. From there I am going to get the relation tau equal to, you can simply say T into R upon J, polar moment of inertia. T upon J into polar moment of inertia. Now if you talk about at center, so at center what will be radius? Obviously we can say, sir, it will be 0. So what will be the shear stress? It will be what? 0. So shear stress at the center will be 0 for round shaft subjected to pure torsion. So that is the one of the very you can say universal result that you have to be keep in mind. Whenever a solid shaft subjected to pure torsion, then there is no any shear stress at what, my dear friends? Center. Okay, it will be 0 at center and maximum at the, we can say, surface. That point you have to be keep in mind. Tau equal to TR upon J. So it is going to be changed. And what is the variation? We can say the shear stress variation is power R ke power 1 na, power of R is what? 1. So we can say shear stress variation is linear. That type of question is also going to ask what is the shear stress variation. So it will be what? Linear. Next, proof resilience may be defined as work done in straightening the material, maximum strain energy that can be stored in a material per unit volume, maximum strain energy that can be stored in a material under elastic condition, maximum load which can be applied. So what is the proof resilience? So maximum strain energy can be stored in material under elastic condition. See, work done straining the material, maximum strain energy that can be stored in material per unit volume. Yes, my dear friends, that is the right answer. We can see the proof resilience is what? Maximum strain energy that can be stored in material under elastic condition. That is called is what? Proof resilience. C for Chennai is the right answer. Next question. A uniform load of length L, cross sectional area A and modulus of elasticity E is held rigidly at the fixed end and axial load P is applied at mid length of the rod, the strain energy stored. My dear friends, what do you mean by strain energy stored? That is, you can say sir, half P into delta, right? What is delta? So simply we can say sir, half P into you can say change in length, half P into change in length, that one is basically. So you can see here I am coming with the answer. So we can say half U equal to half P into change in length. So we can say U equal to half P is W, and what called be change in length? PL upon AE na. So we can say sir, WL upon AE. What is change in length, my dear friends? In case of prismatic bar, PL upon AE, instead of PW is there, so WL upon AE. Just put that value. So we can say sir, half W square L upon AE, half W square L upon AE. Here one more thing, my dear friends, in the question, P is applied load, just see half na here, length cross section modulus E held rigidly fixed and axial load P is applied mid of length, the strain energy is stored. So we can say W equal to P upon 2 na. Here simply we can say sir, W is equal to what? P upon 2, like that na. Reaction just so here I am get W equal to, that is what reaction is, P upon 2, that is also P upon 2. So that just put that value and you will get the P square L upon 8 AE. That is the strain energy method, P square L upon 8 AE. Next question. In case of crystalline and brittle material, criteria of failure that takes place under maximum principal stress is put forwarded by theory of Rankine or Rankine theory, theory of due to the gas theory, theory of Saint-Venant, and theory of Belton and Hague. In case of crystalline and brittle, which type of material is there, my dear friends? Brittle material is there for failure. So brittle material, which theory mostly you are going to prefer? So we can say sir, Rankine theory. Which prefer? That is a basically question from the theory of failure. So Rankine theory you are going to be prefer. So the correct answer will be A for apple is the right answer. Rankine theory is the right. Best for brittle material. Next question. Which theory of failure you will see used for aluminum component? Which component? Aluminum component under steady state loading. Aluminum is there. Aluminum ductile or brittle? So yes, we can say ductile. So for ductile, which theory gives the right? So maximum shear stress theory. Which theory? Maximum shear stress theory. So we can say we are going to use the MST, maximum shear stress theory. So that was, my dear friends, about the, if you talk about some question, we will meet in the some another session, then we will see the some more questions, some more important question regarding the BEL. Okay. So yes, my dear friends, thank you all. And yes, you can join our batch which is running on our panel. So you can join the batch for getting much more insight of the subject. Thank you.